simple bar of diameter 30 mm and at a length of 5 meter is subjected to a tensile load of 100 kilonewtons. Then find out the change in length of the bar. The E value is given. So here what we have to find out change in length. We know the modulus of elasticity is equal to stress by strain, that is equal to P by A by delta L by L. Change in length delta L is equal to PL by AE. By substituting the values from the question, 100 kilonewtons into 5 by area is pi by 4 d square 0.03 square into modulus of elasticity 200 into 10 to the power of 9 10 to the power of minus 3, that is equal to 3.53 millimeters. 3.53 millimeters, 35. Okay, in terms of centimeters, 35.3 centimeters. That is approximately is equal to 35 centimeters. Option B is correct. Which of the following is incorrect in case of stiffness matrix? We have to choose from the options the incorrect statement in case of stiffness matrix. Stiffness matrix is square and symmetric and positive definite, but it is not a singular matrix. So option C is correct. Per code, for bars in compression, the value of bond stress for bars in tension shall be increased by 25%. So option B is correct. In a members, the permissible compressive stress due to bending in M20 grade concrete is given as 7 Newton per millimeter square. Find out the value of modular ratio. We have to find out the value of modular ratio. We know the modular ratio M is equal to 280 divided by 3 sigma CBC. The sigma CBC is permissible compressive stress in concrete, that is equal to 280 divided by 3 into 7, that is given. So 40 by 3 is equal to 13.33. Option B is correct. Assessing the strength of a structural member for the limit state of collapse, the value of partial safety factor gamma M should be taken as. For concrete and for steel we have to know. So by using limit state of collapse, the partial factor of safety that is considered for concrete is 1.5 and for steel is 1.15. Why the factor of safety for steel is less than that of concrete? Because we are going to have a control on steel, whereas we don't have control on concrete. So we have to take the greater factor of safety when compared with the steel. So factor of safety for concrete is 1.5 and for steel is 1.15. So option A is correct. If the sludge volume index of a particular sludge is given as 88 ml per gram, that is sludge volume index is given as 88 milliliters per gram, then find out the value of sludge density index SDI. That is SDI is equal to 100 by sludge volume index 100 by 88, that is equal to 1.136 gram per ml. So option D is correct. If the pressure at any point is more than the static pressure, then the flow is. Pressure at any point is more than the static pressure, the profile of the flow is going to be concave, because the centrifugal forces and gravitational forces are acting in the same direction. Therefore, concave profile is going to appear. Option C is correct. S2 profile, which of the following is correct? We have to choose from the options the correct statement in case of S2 profile. Mildly steep critical profiles are going to be there. In the S2 profile is one type of profile, and in this case flow is more than critical depth. Not correct. The type of flow is supercritical. Yes, the type of flow is supercritical. The type of profile is backwater, not correct. The curvature of flow profile is convex, no, it is concave. So this is not correct. So option B is correct statement with respect to S2 profile. Is a saturated soil used to determine the shrinkage limit has initial volume of 20.2 cubic centimeters, final volume is given, mass of wet soil is 34 grams and mass of dry soil is 24 grams. Determine the shrinkage limit. We have to find out the shrinkage limit SL that we take. So we know the formula with respect to mass of wet soil and mass of dry soil. So M1 minus M2 divided by M2 minus V initial minus V final divided by M2 into gamma W into 100. So where M1 is mass of wet soil and M2 is mass of dry soil. Vi is initial volume, Vf is final volume. Gamma W is unit weight of water. So by substituting these values in the equation 1, we will get M1 is wet soil, M2 is 24 minus initial is 20.2 minus 14.3 divided by 24 into 1 gram per cc, that is equal to 17%. 17%, option C is correct. Compacted soil, G is given, specific gravity and water content is 18%, and dry unit weight is 0.9 times the unit weight of zero air void line. Unit weight at zero air void line. Determine the dry unit weight of the compacted soil. We have to find a dry unit weight of the compacted soil. We know gamma at zero air void line is equal to gamma W by water content plus inverse of specific gravity, that is equal to 9.81 and 0.18 plus 1 by 2.72, that is equal to 17.9 kilonewton per cubic meter. So we can, from the statement in the question, dry unit weight is 0.9 times the unit weight at zero air void line. Unit weight at zero air void line is this much, and dry unit weight is equal to 0.9 times the zero air void line dry unit weight, that is 0.9 into 17.9, that is equal to 16.1 kilonewton per cubic meter. So option D is correct. Concrete containing silica fume exhibits the following. Silica fume is used to reduce the bleeding of a concrete. So option A is correct. Option is an offset is laid at out of 5 degrees from its true direction on the field. Find the resultant displacement plotted on the paper in a direction parallel to the chain line. Given the length of the offset is 20 meters and the scale is 10 meters is equal to 1 centimeter. So we have to find out resultant displacement plotted on the paper in the direction parallel to the chain line. So the resultant displacement occurred on the paper in the direction parallel to chain line is equal to L sine alpha by S, where S is the scale, L is length. 20 meters sine 5 degrees divided by scale is 10 meters is 1 centimeter, that is equal to 0.174 centimeters. 0.174 approximately equal to 0.17 centimeters. So option C is correct. Design speed of a vehicle is 60 km/h and its design coefficient of lateral friction is given of a horizontal curve of radius 150 meters. Calculate the equilibrium super elevation if the pressure on inner and outer wheels should be equal. So super elevation is equal to V square by 127, or where V is in km/h, kilometers per hour, R is in meters, that is equal to V square, that is 60 square 127 into R is 150 is given, that is equal to 0.19. We will get the value of 0.19, that is option A is correct.